Well, welcome to our third lesson in Unit 3. This lesson is titled Solving Inequalities by Multiplying and Dividing. So our last lesson we learned how to solve inequalities using addition and subtraction. In this video you are going to learn how to translate your words into inequalities again, but we will be using multiplication and division to solve those. So we have some properties to review again, just like we had our properties for addition and subtraction. We also have properties for multiplication and division. Now to keep in mind, in this lesson we're talking about, at this part of the lesson we're talking about multiplying and dividing by positive numbers. Very important to keep that in mind. So we can multiply both sides of an inequality by the same positive number without changing the truthfulness of the statement. So as long as we start with a true statement, something like 7 is less than 12, we can multiply by the same number on both sides and end up with a true statement. To write that algebraically, we would multiply by c on both sides, and ac would be less than bc. Similarly, for division, we can divide both sides by the same positive number, and it will still be a true statement. So if we divide both sides by 5 in this example, then we end up with 3 is less than 7. And algebraically, it would be a divided by c is less than b divided by c. Now just keep in mind, those are positive numbers we're multiplying and dividing by. So let's put this into practice. What does this look like if we actually do some practice problems? Solve each inequality and graph the solutions. So x is being multiplied by 3. We undo multiplication by using division. So I'm going to divide by 3, and whatever I do on one side, I must do on the other. 3 divided by 3 is 1, and we have x is greater than negative 9. So the way that we're going to graph that on our number line then, if you recall from our last lesson, there's no equal to with negative 9, so that means we need to have negative 9 is our end point on the number line. And it's an open dot because it's not included. So we want an open dot on negative 9, and it's all the values that are greater than negative 9, which are to the right. So we're going to shade to the right. Over on the right-hand side, our equation says 2/3 r is less than or equal to 6. So how do we solve this one? Well, this one is being multiplied by a fraction. So remember, what we're going to do is we're going to multiply by the reciprocal of that fraction. Just flip it upside down, 3/2, and we'll multiply both sides by the same fraction, which means 6 needs to be put over 1. And when we do that, we can cancel our 3's and they become 1's. Our 2's also cancel and become 1's. And the only thing we're left with is the variable r on the left-hand side. And then we have our inequality, which is less than or equal to. And we can do some simplifying here on the right. We can divide 2 into 6 3 times, and we're left with a 1 in the denominator. So our denominator is just 1, so we can just multiply our numerators, and we get r is less than or equal to 9. So on our number line, we need the value 9. And this one, it has less than or equal to, so this time it's a solid dot because it can equal the endpoint and it points to the left. All the values that are less than or equal to that are solutions. So there are the solutions on our number line. Here are 2 for you to try. Go ahead and pause the video and work on these and bring your answers to class. All right, so what happens when we multiply by a negative number? This is kind of an interesting thing. If we take both sides of an inequality and multiply by a negative number, let's just see what happens. So our directions say complete each inequality with less than or greater than. Well, when we look at 2 and 3, 2 is less than 3, so that's a less than. Negative 2 and 4, negative 2 is smaller, so that's a less than. 7 and negative 1, 7's bigger than negative 1, and then negative 6 and negative 9. Negative 6 is bigger, right? It's less negative, so that one is greater than negative 9. So now, notice what I've done here is I'm going to multiply every single one of these numbers by -1, and then we'll take a look at the inequalities and see what changes. So I multiplied both 2 and 3 by -1. So think about a number line now. Where is -2 and where is -3? Well, -3 is to the left of -2 on a number line, so -3 is smaller, making -2 greater than -3. Again, multiplying by -1, notice the signs changed on both of these. 2 is bigger than or greater than -4. 1 is greater than -7, which means 7 is less than 1, and 6 is less than 9. Well, let's look at our results. When we compare our results, what do we notice? We started with less than, it switched to greater than. Started with less than, switched to greater than. Started with greater than, switched to less than. Started with greater than, switched to less than. So when we multiplied by -1, all of our inequalities switched direction. So that is not a coincidence. So we have another property of inequality that we need to talk about. If we multiply or divide by a negative number, okay, the same negative number, we have to reverse the inequality symbol in order to keep our true statement. So here we have a true statement. 8 is greater than 4. Well, if I go ahead and multiply both sides by -2, I get -16 and -8. Well, -16 is not greater than -8. It is less than. So we need to flip that inequality to keep a true statement. Algebraically, if we start with a being greater than b, and we multiply both sides by a negative number, then we're going to have a times c is less than b times c. Okay, so don't forget to flip your inequality. The same thing happens for division. If we multiply or if we divide by the same negative number, we're going to have to reverse that inequality. So I'm going to divide both sides by -4, leaving me with -3 and -1. Well, we started with a greater than. 12 is greater than 4, but all of a sudden we have a less than. -3 is less than -1. So our statement for algebra is a divided by c is less than b divided by c. So let's go ahead and do some practice problems. So here we go. We have -8x is greater than 72. To get x alone, it's being multiplied by -8. The opposite of multiplication is division. So I'm going to divide by -8. And whatever I do on one side, I have to do on the other. Now, -8 divided by -8 is 1, right? These cancel. And I just have the variable x. And we need to flip our inequality. So when I move this down here, it's going to flip the other way because I divided by a negative number. Okay? 72 divided by -8 is -9. So -9 is the value I need on my number line. And let's go ahead and take a look at what the graph would look like for that. Now it's an open dot because there's no equal to, so I'm going to use an open dot. And I'm going to go to the left. All the values that are less than -9 are to the left. All right, let's go ahead and look at letter B. This one has x being divided by -5. Well, what's the opposite of division in math? The opposite of division is multiplication. So I'm going to multiply by -5. And whatever I do on one side, I have to do the exact same thing to the other side. So my -5 is over 1, and it cancels with the -5 that's being divided. So I just have x on the left-hand side, and then I'm going to flip this. Remember, this flips anytime you multiply or divide by a negative, so it's going to go the opposite direction from what it was going. So x is greater than or equal to, and a negative times a negative is a positive. So I get x is greater than or equal to 15. So this time I have the equal to with it, so it's a solid dot. So we want a solid dot on 15. And all the values that are greater than 15 go to the right. So my graph would look like that. So another caution here, don't change the direction of the inequality just because you see a negative sign. Okay, here's an example. 4x is less than -24, but I would only divide by a +4. So I don't have to flip my inequality unless I multiply or divide by a negative in the process of solving for the variable. Here are two for you to try. Go ahead and do these on your own and bring your answers to class. And then here's some practice translating. Ryan has a $25 gift card for a coffee shop where his favorite latte costs $4.50 with tax. What are the possible number of lattes that Ryan can buy? Well, we know that he can spend up to $25. He can spend all of it, and each drink is $4.50. So we're going to take $4.50 times the number of lattes, and that has to be at most $25. So let's translate those words into mathematical terms. So we're going to take 4.5 and we're going to multiply it by the number of lattes. I'm just going to say 4.5 L is at most. That means it has to be less than, but it could be equal to. He could spend all of his money, $25. What are the possible numbers? So if we wanted to solve this, we would need to get L by itself. And the way we would do that, since it's being multiplied by 4.5, we would divide by 4.5 on both sides. Okay, and then we're going to have those canceling, and we would get L is less than or equal to 25 divided by 4.5. Sure, L is less than or equal to 5.5, and that repeats. So you can't buy part of a latte, so we're going to get L has to be less than or equal to 5. You can get up to 5 lattes, but no more. That'll do it for this video. We'll see you next time.